Hello everyone, in this video we'll learn a program to create a list of n nodes and insert a new node at the end of a linked list. A linked list is a linear dynamic data structure to store data items. A linked list consists of items called nodes which contain two parts. The first part stores the actual data and second part has a pointer that points to the next node. The first node of a linked list is called head, while the last node of linked list is called tail. As we see, the last node of the linked list will have its next pointer, that is null. That means it will not have any memory address pointed to. Since each node has a pointer to the next node, data items in the linked list need not be stored at contiguous locations. The nodes can be scattered in the memory. We can access the nodes anytime as each node will have an address of the next node. Insert node at the end of a linked list. First of all, create a new node and make sure that the address part of a new node to null, that is new node next is equal to null, and traverse to the last node of a linked list and connect the last node of a list with the new node, that is last node will now points to the new node, that is last node arrow operator next is equal to new node. Let's see the program to insert a node at the end of a linked list. Then how to create a linked list. The first step of creating linked list of n nodes starts from defining node structure. Every node having two parts. The first part is known as data part and the second part is known as address part. We need a custom type to store our data and location of next linked node. This is our node structure. Struct node. Struct is a keyword. Node is the name of the structure. Structure having two members, data and next. Where data is the data you want to store in the list, and star next is a pointer to the same structure type. Node is the structure, name, and struct is a keyword. The star next will store location of next node if exist, otherwise null. The node structure may vary based on our requirement. You can also have user defined types as node data section. Then declare a pointer to node type variable to store link of first node of the linked list. You can also declare variable of node type along with node structure definition. There are two ways to define the structure variable: inside structure definition and outside structure definition. Now in this case, structure variable defined inside the structure definition. After that, declare two functions. First function is for create a linked list And second function is for traverse a linked list. Void is a return type. Create list is the name of the function, and function having one argument, that is n. N denotes total number of nodes in a linked list. In second function, void is a return type and traverse list is the name of the function. Then inside the main function, declare a variable n. N is for total number of nodes in a linked list. Then input number of nodes to create from user. Store it in a variable, that is n. After that, call a create list function. When this function call, control transfer to the definition of create list function. With the help of create list function, we can create a list of n nodes. Void is a return type, create list is the name of the function, and int n. N is the parameter. Inside the function definition, declare two more helper variables of node type, that is struct node star new node comma star temp. Star new node and star temp are two helper variables of node type. If the value of n is greater than 0, then create our first node, that is head node. We use dynamic memory allocation to allocate memory for a node, that is head is equal to struct node star malloc function, then size of struct node. With the help of malloc function, we can dynamically allocate memory. If there is no memory to allocate for a head node, if head is equal to null, then print some error message and terminate the program. Otherwise, move to the next step. Then input data from user and assign to head using head arrow operator. Data is equal to data. At first, head node points to null, that is head arrow operator next is equal to null. Now we are done with head node. Then we should move to creation of other nodes. Copy reference of head to some other temporary variable, that is temp. Temp is equal to head. Now we will use temp to store reference of previous node. Then create n-1 nodes and add to the list. Apply a for loop for I is equal to 2, I is less than equal to n, and I++. Inside the definition of for loop, allocate memory and assign memory reference to a new node with the help of malloc function. If memory got allocated successfully, then read data from the user and assign to data section of new node. That is new node arrow operator, data is equal to data, and make sure that new node points to null. Now link previous node with newly created node, that is temp arrow operator next is equal to new node. Then make current node as previous node using temp is equal to temp arrow operator next. Then I plus plus. Again repeat all the steps, and after that call the traverse list function. When this function call, control transfer to the definition of traverse list function. Inside the definition of traverse list function, create a temporary variable for traversing and return if list is empty. If head is equal to null, then cout list is empty. Otherwise, assign reference of head node to a temp variable. Temp is equal to head. Then repeat below steps till temp not equal to null. And inside the definition of while loop, temp arrow operator data contain the current node data. You can print it or can perform some calculation on it. Once done, move to the next node using temp is equal to temp arrow operator next. Then again go to step 97. Again check the while condition. Temp is not equal to null. Then temp arrow operator data contain the current node data. Once done, move to the next node using temp is equal to temp arrow operator next. After that, declare a function insert node at end. Void is a return type. Insert node at end is the name of the function, and this function takes one argument, that is data. And inside the main function, we have to call the function insert node at end. When this function call, control transfer to the definition of insert node at end function. Void is a return type. Insert node at end is the name of the function, and this function takes one argument, that is data. And inside the body of insert node at end function, firstly create a new node, and after that allocate memory to a new node with the help of malloc memory allocation function. If the list is empty, we can say if new node is equal to null, then new node become first node. Assign data to a new node and set next pointer of new node to null as it's the last node. Then traverse the list till the last node, that is while temp not equal to null and temp of next not equal to null, and then assign temp to next to a temp variable, and temp to next is equal to new node. We can say traverse the list till the last node and change the next of last node with the help of statement temp to next is equal to new node. And after that, with the help of cout, display the message data inserted successfully. With the help of a statement new node to data is equal to data, we can assign data to a new node. And with the help of statement new node to next is equal to null, set the next pointer of new node to null. And with while loop, traverse the list till the last node and change the next of last node. And finally display the message data inserted successfully. And then again call the traverse list function. Traverse list function display the data after insertion onto the screen. Run this code. Now after the execution of this code, first of all enter the total number of nodes in a linked list. Total number of nodes in a linked list are 3. Enter the data of first node, enter the data of second node, then enter the data of third node. Data in list is 12, 13 and 14. Then enter the data to insert at the end of a linked list. We want to insert 15 at the end of a linked list. Data inserted successfully. And data in the linked list is 12, 13, 14 and 15. This is all about how to insert a node at the end of a linked list.